Hi friends, this is for Texas Instruments from the team Cosmo Quickfrost of MEPCO Engineering College. Let's go to see my design. My design first of all followed by the generation process. My generation process is based upon the patent rights of Nikola Tesla in 1906. Even I have taken this video in the night time. The radiant energy is absorbed by this aluminum foil. The aluminum foil acts as this antenna. The antenna is connected to the diode 207. I followed the output of the diode to the capacitor. The output of the capacitor I have given to the CE amplifier. You can visualize the CE amplifier design here. The CE amplifier design is followed by the Darlington circuit. The Darlington circuit output has taken to the exhaust fan, which acts as the primary cooling system of my design. The primary cooling system is followed by the secondary cooling system consists of DRV. The DRV is fitted as here. The secondary cooling system has two pipes from the exhaust fan setup to the secondary cooling system, where the temperature of the living room is controlled by the internal temperature sensor of C2000, which is the launch pad we have used in this project. Let us dump the C2000 into the living room. I have to consider the temperature of the living room. Let's go and have the action of my design. First of all, the input given from the capacitor of my generation pot is followed by the CE amplifier circuit. Output of the CE amplifier is given to the Darlington circuit. The output of the Darlington circuit is taken to the exhaust fan. I have placed the pipe at the end of the primary cooling system. Now you can watch the primary cooling system. I have placed the ice inside the primary cooling system. Now you can easily watch that. The ice is meant for the primary cooling system. The ice, the cool air, the cool breeze from the primary cooling system is drop out to the pipe followed by the secondary cooling system. And you can see the rotation of the EVM, which can further send the cooling breeze to the living room. And I have to mention that the EVM also has the power supply from the power generated by the circuit. The voltage regulator maintains the 12 volt output of the Darlington circuit to the 5 volt range. The 5 volt is given to the EVM as I mentioned earlier, and the EVM continues to rotate. And the next block I have to show you the working condition of my living room. As I earlier dumped the C2000 into the living room.
Hi, I am going to explain about controlling system of this project. First, I am using a 3 LED for low, moderate and high temperatures. I use a 4 ports for high, moderate and low temperature, as well as a PWM input of this project. I give 3 different conditions for this LEDs. When temperature is greater than 43, a red LED get closed. When temperature is between 43 to 41, blue LED get closed. When it reaches less than 41, it get blink as green LED.
Let I continue that to the core. As I dump the C2000 into my living room, where the cool breeze is sent out by the secondary cooling system, which has primarily sent out by the ice in the primary cooling system. Now you can watch that. The exhaust fan in the primary cooling system sends the cool breeze from the primary cooling system to the secondary cooling system. The breeze out is continued by the EVM. The living room has the capacity to hold out the cool breeze in the living room. The C2000 internal temperature sensor maintains the temperature, where it glows the green LED, where the temperature reduces to 39 degrees Celsius. As I show you the programmable model of my design, where the temperature is 39 degrees Celsius. and just it reaches to 40 degrees Celsius. When I have designed the 41 degrees Celsius to the blue LED, since didn't reach us the 41 degrees Celsius, it still grow on the green LED. As the temperature decreases to 39 degrees Celsius, the third condition glows. As the third condition, we don't need more breeze to enter the living room. So I decrease the speed of the EVM. So some amount of cool breeze will enter the living room. So it has a stable temperature at the internal temperature sensor of the C2000. After I takes out the C2000 launchpad from the living room, dumped inside earlier. This part I have dumped earlier, C2000. Now you can visualize that the change in temperature. The green LED dims and the blue LED starts to blink. The red LED starts glows. The temperature rises 43 degrees Celsius. You can visualize that. After I get out the launch pad from the living room system, temperature has increased from low, moderate and high. And I have to show you the charge stored in the capacitor. I do the demo. Placing the multimeter to the capacitor, you can visualize that 1.82 volt charge within 15 minutes. Okay. And I have to increase the load I have put earlier, and I have to check that. Let's go and check the load I have put there. Let's check the rechargeable battery, and I have to check the voltage present in the rechargeable battery. Now come, we check the voltage. The voltage present here is 4.90 volt. Let's go on charging, and then I have connected the C2000 kit, which has activated. On the whole, I show you the loads which I have connected. First, the load I have connected is the exhaust fan, which drives on the voltage of 12 volt. Then I have connected to the GRV. Then I have connected to the rechargeable battery. Then again to the 5 volt C2000. Come on, now let's check the charge factor of the rechargeable battery. Now we can simply notify the increase in the voltage of 5.02.